Hello friends, this video on Biomolecules Part 7 is brought to you by examfear.com. No more fear from exam. Correct. Now we'll talk about the cyclic structure of glucose. So chemists have seen that the straight chain structure of glucose proposed till now does not satisfy a lot of observation which was seen for the carbohydrate, that is glucose, right? So it does not satisfy some of the facts and some of the reaction cannot be explained by the current structure of glucose, because the current structure of glucose was this. So this was not able to explain the reactions and the facts about the glucose. And one of them was this has aldehyde group, but still it does not give 2,4-DNP test. It does not give shift test. Also, it does not form hydrogen sulfide addition product with NaHSO3. All these are pretty much mandatory for a compound which has free aldehyde group. Also, the pentaacetate of glucose, they does not react with hydroxyelamine. That indicates that there is absence of free aldehyde group. So if we take the pentaacetate of glucose, for example, this is my pentaacetate of glucose, CH3, CH2, OCO, CH3. This is my pentaacetate of glucose, right? So this, when you react with hydroxyelamine, it does not react, but glucose reacts. Glucose, that is, we have seen actually. So when this reacts with my hydroxyelamine, it's fine. It is NH2OH, I believe, right? But this works, this doesn't work. The question is why? Why this particular glucose reacts with hydroxyelamine, but the pentaacetate of the same glucose does not react? That indicates that there is no free aldehyde here. That means this structure is not correct. There has to be something else. And this was clearly telling that must be a cyclic group here, and this aldehyde is not free. Because had this aldehyde been free, had this been the correct structure, this reaction would have taken place. Correct? So that means this structure is true for some cases, but that clearly shows, because we have seen that a lot of assuming this structure to be true, because this structure also we got from experiment itself. The structure is true from some cases, but for some cases the structure is not true. That means the structure changes based on medium. If it's aqueous medium, the structure changes. If it's dry medium, the structure is different, right? Also, it is seen that for the glucose, it exists in two different crystalline forms. That is alpha form and beta form. The alpha form of glucose has a melting point of 419 Kelvin, and the beta form of glucose has a melting point of 423 Kelvin. So with these two different crystalline forms, it was pretty obvious that glucose exists in various forms. Correct? So this is one of the structure, but there are other structures also possible, because there is alpha glucose, there is a beta glucose which has different melting points, and they are obtained using different process. The alpha glucose is prepared from concentrated solution of glucose at 303 Kelvin, while the beta glucose is obtained from the similar solution at 371 Kelvin, that is hot and saturated aqueous solution. So with this, it was pretty obvious that this figure is not the correct one. So they came up with two figures, that is cyclic one, and they are alpha D-glucose and beta D-glucose. So what are the structure? They told that, if you see, I'll just show you how it works. You have an aldehyde group, and when you react with alcohol, what will happen here? This oxygen, slightly negative, slightly positive. This carbon has slightly positive charge. This oxygen has the lone pair will attract this carbon. So what you get here is RCO minus HOH and R dash. Since this oxygen gave electron to this carbon, oxygen gets positive charge. Correct? So somebody has to leave because oxygen is an electronegative element, doesn't want positive charge in it. This hydrogen will say I will leave it as H plus. And this hydrogen will be attacked by this O minus. Right? So with this you get R COH H and OR dash. This is the reaction to form hemiacetal. So if you see, this is a hemiacetal. This is a carbon here, OR group attached, OH, R and H. This is a hemiacetal. Similar thing will happen here. So this is a aldehyde here on this carbon. This will be attacked by one of the OH. Now the question is which OH? So these OH will not be able to attack. Why? Because the orientation will not be there. Correct? So this is like this. If I have a long rope, right, there's a positive charge here, and even if a negative charge is there, they'll not be able to attract because the orientation won't allow. But if there is a negative charge here, right, it can attract and form a bond. It can form a circle easily. Correct? Why? Because if there's a positive, there's a negative here, this negative will not be able to bend. But if there's a long chain, the last negative charge will be able to bend easily, right? Will be able to join this positive charge. Space. It's all about space. So this carbon is the one which will attack. This has a lone pair. This will go in this direction, slightly negative charge, slightly positive charge. It will attack. Similar to this fashion, what will happen is this will form something like this. It will form beta or alpha D glucose. It will have two isomers because the carbon, the OH can attack either from this side or from this side. So based on that, we'll get two different structures. So let me show you with this reaction, how the reaction works. This is my glucose, 1, 2, 3, 1, 2, 3, 4, 5 and 6 carbon. So this CH2OH, this oxygen is going to react, right? Attack this particular carbon. Go in this direction, slightly negative, slightly positive charge. So what will happen here is this bond will form, oxygen will get a slightly positive charge, right? So I'll show you the reaction here. Oxygen with the hydrogen here. Because this whole thing went. Correct? Slightly positive on this oxygen, it will want to get rid of it. This hydrogen will say, okay, I'll go, and this will get attached to this carbon, this oxygen O minus. So what you get here is OH, 1, 2, 3 carbon, C, this is O here, and CH2OH. Now if you see this particular reaction, it can happen from this side or from this side. So in one case, hydrogen will be on this side. In another case, hydrogen will be on this side. So this is called alpha D glucose. Why D? Because OH is here, D side. Here also OH is here, D side. So both are D, but this is alpha and this is beta. Correct? So these are the two different forms, alpha D glucose and beta D glucose. And we'll see that the alpha D glucose, in fact beta D glucose is more stable. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.